Good evening, students. Today I will continue the expansion of the gas, the remaining part. Okay. So in the previous lecture, I have completed up to the Charles law and the pressure law. So according to that, for a gas, there are two kinds. We can change the, if we change the temperature for a gas, then there are two parameters which are going to be changed. First one is the pressure and next one is the volume. So based on these two things, we have two type of coefficients. These two type of coefficients, what's are they? Basically, volume coefficient at, this is the first one, at constant temperature, at constant pressure, and the next one is that pressure coefficient at constant volume. So these are the two coefficients that is basically calculated for if we change the temperature. Okay. Then what is this volume coefficient? Volume coefficient is defined as at constant pressure. If we increase the temperature by 1 degree Celsius, then for a particular amount of gas, the volume expansion will be, the volume expansion is given as the gamma P. So for this it is gamma P, and for this at constant volume, so it is gamma V. At constant pressure, that's why it is represented as gamma P, and for constant volume it is represented as gamma V. Later I will show you this gamma P and gamma V are the same. So let us discuss how it can be same. So first of all, let us take a gas at 0 degree Celsius temperature for a particular gas, and its initial pressure is P0 and initial volume is V0. Okay. Now, if we increase the temperature from 0 degree to T degree Celsius. Okay. Now we can for this temperature increase, how we can increase this temperature? We can increase the temperature by two ways. First one is at constant volume, the pressure is increased. The pressure becomes that is PT. And next one is that at constant P, that is pressure, the volume, let us consider it is VT. Okay. That is VT. Hopefully it is clear. Now, according to the pressure law, what we can say about this PT? PT can be written as P0 of 1 plus T by 273. And what is this VT? According to the Charles law, it is like this. Right? So, if we draw the diagram like this, so suppose this is P0, V0, this is one change, this is another change. This is basically PT and this is basically VT. And after, so here for PT, pressure is changing when the volume is constant. So it becomes PT and V0. And for this, pressure is constant and volume is changing. So P0 VT, right? T degrees Celsius, both of its temperature is being constant, that is T degrees Celsius. Okay. So therefore, according to the Boyle's law, what we can write, according to the Boyle's law, we can write PT V0, that should be equal to P0 VT. We already have the value of PT and VT. So we will just put it here. So if we put it here, what we are getting, or one thing is that instead of this T by 273, we can write it here as it is gamma VT and this becomes gamma PT. So let us just put the value. PT will be P0 V0 1 plus gamma VT. That should be equal to P0 V0 1 plus gamma PT. Right? So this will be cancelled out. 1 will be cancelled out. So gamma V equals to gamma P. So two coefficients of the volume expansion for a gas, it's same, that is gamma V and gamma P. Hopefully it is clear to all. Next, I will start the Dalton's law of partial pressure. So what does it is saying? It is saying basically that if two or more gases are mixed together and if there is no chemical reaction between these gases, then at a constant temperature, the pressure will be equal to the partial pressure of each of the summation of the partial pressure of the each gases. So, pictorially, if I say this, how pictorially I get? Suppose this is a container. Here G1, this is the first gas. G2, this is the second gas. This is the G3, it is the third gas. At constant temperature T degrees Celsius, these three gases are combined with each other. And the condition is that these three gases are not reacting with each other. They are chemically inert. So, if this gas has a partial pressure P1, it has a partial pressure P2, it has a partial pressure P3, then according to Dalton's partial pressure concept or partial pressure law of partial pressure, this total gas has a pressure P. So we can write as P equal to P1 plus P2 plus P3. So this is the basic Dalton's partial pressure law of partial pressure. Hopefully it is clear to all. And now how you will find this partial pressure? Basically it can be find out by the formula P1 V1 plus P2 V2 by V1 plus V2. If third gas is there, so it will be P3 V3 plus V3. Like this it will go on. Okay. So next concept is that the absolute zero temperature. So what do you mean by absolute zero temperature? It is the temperature where the volume of the gas becomes zero. Basically it converts into liquid. So there is no existence of gas at all. That's why it is called the absolute zero temperature. So what is this? It is basically minus 273 degrees Celsius or 0 Kelvin, at which there is no existence of any gas, it becomes basically liquid. That's why it is called the absolute zero temperature. Now the thing is that already you have studied the part that is ideal gas equation. What is the difference between ideal gas and the real gas? Kinetic theory of gases. These parts also you need to study. Okay. Now another thing is that the universal gas constant, that is capital R. Already you know what is capital R and what is the unit of this, already you know. Okay, if there is a problem in that part, please go through your class 10 physics book. Okay, and now the thing is that another thing is remaining, that is some sort of question answer corresponding to this chapter. First question is that if a car is moving, then why the pressure of the tire of that car is increased? Why? Basically, when a car is moving, that means there is a friction force is there, and as the friction force is there, which means that to overcome that friction force, some amount of work done is ongoing on that tire. That's why there is the pressure is being increased. Okay, so if you blown up a balloon, whether the Boyle's law is applicable or not, basically we know that according to the Boyle's law, P is directly inversely proportional with the V, right? So which means if the volume increases, then the pressure is decreasing. But if we blown a balloon, then what we are seeing? We are seeing that pressure is increasing as well as the volume also increasing. So does it violate the Boyle's law? Actually, it does not violate the Boyle's law. Basically, why? So the thing is that for the Boyle's law, mass should be constant. But when we are blowing the balloon, their mass is not constant at all. The mass of the air is also increasing inside the balloon. That's why it is violating the it does not violating the Boyle's law. Okay, so this kind of questions you need to prepare, okay, from this chapter. So the expansion part is completed. Thank you.